Yeah, I mean,
Okay, I just wanted to make sure I wasn't imagining it.
okay. 1 second. 1 second. Can everyone see my screen? Beautiful. All right. So where was I? Right. So we can be looping until the end of the string, but if we're looking for something that's like a word like that, wharf, if we're looking for a word and we're looking and we start here, right? And we look for this amount and we see that that L isn't here. So then we look at the O and we see that it's not the same. Why would we check RLD if it's not even the same length as this? If where we are in our loop, if what's left is less than what we're looking for, that means it can't be there if we haven't found it yet. So we can just stop there. So another way of putting this is I is less than or equal to, whoops, is less than or equal to source.length minus search value dot length. Because that means the source, the length of the entire word we're looking through, if that, if I is greater than the difference between that and our search value, then that means we can just stop. And then we just increment by I, like normal. So, now that we did that, we have to actually get our like substring that we're comparing from our source, right? Because the substring could be more than one letter. So how do we do that? We can write another for loop in here, sure, but there's actually a method that you guys should get familiar with if you didn't know about this before. And it's fine if you didn't know about this before because now I'm going to tell you, okay? So we could say let sub is now going to be equal to source dot slice. Slice, if you pat, is a string method. And what it does is it takes multiple arguments that are all optional. If I don't pass anything into slice, sub is just going to be a copy of source. However, if I pass in two numbers, I'm saying it where to start and where to end. So we're going to start at an index, and it'll be including that thing at that index, and ending will be where to stop, not including the letter that's there. So we want to start where we are in the loop, and then we want to go plus search value dot length, right? We want to go as far as the search value's length is, right? So that's our sub, and then we could say if sub is equal to search value, if that thing is what we're looking for, we can return I. And once we make it out of the loop, we can return -1. So let me just show you really quick how slice works, right? So we have hello world. Console.log hello, right, dot slice invoked. What we get in the console is hello world. What if I passed in a 1? What would happen? That means we're starting at index 1. And since we didn't pass in another argument, we go until the end. So we started at index 1, which is the E, and we went until the end. So that's why we see hello world. And if we wanted to get like if you wanted to slice off the middle, we would get like we could start at index 3 and go until index 7. So we get low W, right? So where is index 7? We have 0, 1, 2, 3, 4, 5, 6, 7. The second O is at index 7. However, this ending argument is not inclusive, okay? That means we stop and we don't add the thing at index 7. We start at index 3 and add the thing that is at index 3, and we stop at index 7, but we don't add what's at index 7. Does that make sense? It makes sense when I say it to you normally. However, this will be like a little confusing to grasp when you're actually using the slice method. So, if you guys get confused, I'm going to post a link in the Slack after I'm done talking about a nice website called MDN, which is basically Mozilla's documentation of JavaScript, okay? What you can do in Google is you could do like string.slice JavaScript MDN, right? Just make sure you put MDN in there, and it'll be the first thing. And it gives you a detailed description with examples and descriptions of all the arguments that these methods take, all right? I will Slack you the slice one later, okay? However, that is how this function works. We initiate our start value, whether it's going to be 0 or wherever the person passed in a number. We start looping there. We get our thing we're checking, because if we're checking like WO, right? That means we have to check two things, right? We can't just look at source of I, because source of I will just be H, right? What we need to do is we need to take source of I plus however long, we need to go however long the search value is, right? So we need these two things. So we start at 0, and we go until we're at I, which is 0, plus the length. It needs to be I plus the length, because what if I is like 4, right? 0, 1, 2, 3, 4. We want to start here at this 4, but we want to go until 4, 5, 6, right? So we need to do 4 plus 2, 6. We need to go that long. So that gives us the substring here, and then we could see if sub is equal to that search value. If we found it, we stop and we just return I. Returning, the return statement, when JavaScript hits that line, when we hit line 8, the entire function stops. The loop stops, the function stops, okay? Because we've found our answer. Functions return one value, always, okay? So, however, let's say sub is never equal to search value. The thing we're looking for just isn't in there. That means we will make it out of the loop, and then we could just return -1. Any questions on this?
Would you also be able to walk through a solution without using slice? Because the directions clearly said don't use slice. So my partner and I were trying to think through this without using slice.
The directions said don't use slice for my index of?
Pretty sure, yeah.
Or
I thought at the bottom
I know it says you can't use slice in my slice, but I think that's fair game for this problem.
Oh, okay. Oh, I thought it was for... Oh, okay. I thought it was for this one as well. Okay.
For my slice, it wouldn't make sense to use slice, because then that's like pretty much cheating. But I could, but I feel like just for the sake of time, it would just be too annoying. Okay. Because basically, what slice is saying, like, let return string equal empty string, and you're basically saying, like, a for loop, like, let I equal start, I is less than end, I plus plus, and all you do is just return string plus equals, like, string at I, right? That's pretty much what the slice method is doing. But you could just use slice, because it's the same thing.
Got it. Okay. Yeah.
Any other questions on this solution?
Yeah, a question. You did the example of the slice method with 3.7 at the bottom. Why did a W pop up on the end? Because in the index, we're counting number 3 as that second L, and then the second O in the word world as 7. So why did a W pop up? Because it was hello slice 3.7.
Yeah, so we would go until index 7, but we wouldn't include index 7. So we don't include index 7, and index 7 is this O, right?
Yeah.
So that means we made it to the W, right?
We ran every value from 3 up until
7.
that index 7 value.
Yes.
Oh, so it's LO space W.
Yeah. What I recommend you guys doing with all of these methods, if this is like your first time being exposed to them or using them, open up your REPL, make some string variables, and just play around with slice. That's really how you learn these things best, right? By just playing around with them. Okay? So, what are you guys doing over here? Okay, so you want me to do bacteria time. Bacteria time. So this is what I was talking about before. When sometimes while loops are actually easier to reason with than for loops, right? So bacteria time basically would take a current number of bacteria, and we need to say how much time will elapse until we reach our target number. So there's some rules for this problem, right? There's some basic rules. Like, after 20 minutes, the bacteria doubles, right? So keeping that in mind, we can say, first off, I think there was like a edge case, right? We could say if target num is less than current num, right? That means that if we already have our target number, we can just return target num must be greater than current num, right? And just so you guys know, do you see how this if statement, what's going on inside of here, is only one line? If that's the case, I can do that. Only if it's one line, okay? So if this is less than the current num, that means we can just stop our function immediately and return this message. Hey, listen, what you're looking for is actually, we already have that. Or it might be more, right? So now if we make it past here, we can assume that target num is actually greater than current num, right? So the current number of bacteria we have is actually less than the target. So now we can say let minutes. And we could set that equal to 0. So now we can do our while loop. So while current num is less than target num. While current num is less than the target. What we can do is right away we could say current num is now going to be times equal to 2. What that means is current num is going to be equal to current num times 2, right? We are doubling current num. We are doubling the amount of bacteria. But times equals is shorthand, so I'll do that. And then we could just do minutes is now going to be plus equal to 20, right? So if the current number of bacteria we have is still not enough for the target num, then we can multiply the current number of bacteria, and then we can add 20 to the minutes. Then when we break out of here, we can just return minutes. And that will be our answer. Any questions? Any questions? All right. So basically now, we are going to go into basically now what we are going to do is we are going to go into coercion and truthiness, right? So what do I mean by coercion and truthiness?
I just had a quick question. Why did we finish bacteria with a while loop?
Did you say why?
Yeah, why did we do it with a while?
Well, it's just kind of easier to think about this way, right? Like, while the current number, like, if you just say it in your head, right? Like, while the current number is less than the target number, we can just multiply and then add to minutes, right?
So if we're dealing with more than one problem, it's better to use a while loop?
It depends. I mean, you could solve this problem using a for loop. It's just, to me, it was easier to think about this with a while loop. You know what I mean? A good thing for you guys, if you guys want to practice your looping, all of your problems that you solved with for loops, try and convert them into while loops. And all your problems that you solved with while loops, try and convert them to your for loops on your own, you know? That'll help you really understand what the difference is and how they are ultimately the same. If you want some more practice. Make sense?
Right.
Because, like, when to use this and when to use this is completely up to you. There isn't, like, a set rule, like, you should use this when you're doing this, you should use this when you're doing this. It's what you feel most comfortable with. So, anyway, what do I mean by coercion in the first place? What does that even mean? We'll talk about coercion before we talk about truthiness. So, coercion is like, when I say, there's certain types, right? Like, there's a number, there's a string, there's null, there's undefined, there's Boolean, there's object, right? So we're not going to talk about objects yet, but how can we find out what a type of is something, right? So we can literally do console.log type of, whoops, 5, right? And what we get is number, right? And this actually returns us a string. So we could say triple equals to number. And that's true, right? So that's how we get the type of, right? So if I do console.log 5 plus 5, we get 10, right? But what if I did 5 plus string 5? What do we get then? We get 55. Aha. So this is what I mean by coercion. And this is implicit coercion. So what this is doing is JavaScript is actually saying, okay, I see we're adding a number with a string. That means it's just going to convert this one into a string, and then it's going to add the two strings together, right? So if I do let num equal 55, and I say console.log type of num, what we get is number. However, if I do num plus equals a 3, our type of num is now a string. And if we console.log num, what we get is 553. However, it's not 553, it's the string with the characters 5, 5, and 3. Does that make sense? So this is concatenation with strings. Now, that's one way to turn something into a string. That's one way to do concatenation with a string. However, what if we just wanted to just make 55 a string, right? We could do plus equals, we can do something called explicit coercion. And these are called global objects. you can type in string, and this is available to you in the JavaScript universe, okay? You type in string, and you invoke this, and you pass in num. You console.log type of num, oh wait, sorry, num is now going to be equal to string of num. And we get string. And we just console.log what num is, and what we get is 5.5. However, it's a string, right? So this is called explicit coercion. When we are telling JavaScript, okay, now I am going to pass in a number into the string, and we're going to make it a string, right? However, when I do num plus equals an empty string, if I didn't do this, it was a number before, and then I just added an empty string to that number 55, and now it's a string. This is implicit coercion. This you can't control. JavaScript is just always going to do this for you, okay? Does that make sense? Any questions on why this is happening? All good? All right. So we can make something into a string like that, right? But what if I had let string equal 100? Can I make that into a number? Yeah. How do you think? Like this. Now we get the number 100, right? What if I had this? What if I tried to convert 100A into a number? Now this is what we call an error, not a number. NaN stands for not a number. And not a number is very, very specific. It is a big error. It means you're trying to do a mathematical equation involving numbers or coercing something into a number that can't be, you know? So, but then you're saying, why is there a number here, right? That's because type of NaN is actually number. Okay? Can't explain that to you. Just like console.log type of null is actually going to be object, okay? This is actually a bug in the foundations of the language of JavaScript because null's type is null. Null is its own type. However, this type of returns object. So this can be very confusing sometimes, okay? Just for your information. So when you're trying to coerce things like this into a number that can't be, what we get is not a number. However, if it is a number, if it can be changed into a number, what we get is a number, a real number. And another way to do this, instead of doing it like this, we can do, this is shorthand, ready? String is now going to be equal to plus string. The plus in front is doing the same thing as the number. Does that make sense? Any questions so far?
Yeah, if there's shorthand for making a string a number, is there shorthand for making a number a string as well?
That would be this.
Oh, okay, perfect.
If you plus equals anything to an empty string, whatever that thing was will be a string. You can convert anything into a string. Anything. Numbers are different though. Any other questions? Cool. So that's type coercion with strings and numbers. Now, the next type of coercion I'm going to show you is going to be a segue into our next topic, which would be truthiness. Okay? So that all has to deal with coercing a value into a boolean. Okay? How do I coerce something into a boolean? Let's num equal 10. Num is now going to be equal to boolean num. So what do we get here? We get boolean and we get true. Why did we get true? There is a very specific reason why we get true. Every single number except 0 will be coerced into true. 0 gets coerced into false. -10 gets coerced into true. Every single number besides 0 gets coerced into true. When I say gets coerced into true, that is what truthy means. Truthy means if this value coerced into a boolean is true. Whoop. Falsy means if value coerced into a boolean is false. That means since every number besides 0 is truthy, there's an infinite amount of truthy values. However, there actually aren't that many falsy values, so it's very easy to keep track of what's falsy versus what's truthy. What's falsy is obviously we have false, we have 0, we have empty string. Empty string is a falsy value. Any other string with length is truthy. Null is a falsy value. Undefined is a falsy value. I know I'm missing something. I feel like I'm missing one thing. Let me see. Oh, not a number is falsy for sure. Yeah, and that's it. Okay. These are the only values that are falsy. Any string with length is truthy. Any non-zero number is truthy. And then all objects like functions and arrays and objects, those are all truthy as well. Okay? So when I say coerce so when I say truthy, I mean that's how you coerce something into a boolean, right? And I showed you that there's ways to do shorthand for numbers and strings, right? So there must be some kind of shorthand to coerce something into a boolean, right? That would be this. So let me do this. So console.log, whoops, console.log 0 bang bang. What is that? That's false. What if I did 100, 1,000? What we get is true. The bang bang, the double bang, coerces that value into a boolean and returns its value. It's like boolean value. It reflects its truthiness. However, one bang reverses it. Okay? One bang reverses it. So bang 0 is true. The bang operator is sometimes called as the not operator. Not 0, we get true, right? No, not 0 is true. Not true is false, right? Does this make sense? Nod your heads if you agree. Nice. Nice. Okay, cool. So that's, there we have that, and there we have, right? So a little bit more about truthiness, okay? So let's say if 5 is equal to 5, right? This triple equal sign returns true or false. Okay? 5 is triple equals to 5. So we get here. What if I did this? Would I get here, or would nothing happen? Nothing happens. What about now? Would something happen now? Something does happen now. Never use the double equals operator, okay? Never. Never use this, or I will kill you. No, I'm just kidding. I won't do that. But never use this, okay? Never. Because it has, you can Google this on your own. I won't get into this. The double equal sign runs by its own rules on how to compare things. And it actually coerces values. Right now what's happening is it coerces this into a string, I think. Or it coerces this into, I can't remember which one. It's a long, complicated list of rules, but it does type coercion before it compares the values. So this kind of makes sense, but then, like, I think, like, false is double equals to an empty string, I think. Yeah, this should never happen, right? Because false and an empty string are just two completely separate things. Never in my life do you want this to be equal, right? So that's why we do the triple equals, because that takes type into account and doesn't have any set of rules. However, what if you don't care what the value is in your if statement? You just want it to be, like, not 0, right? Or something. So what if you just did at 5, if 5? This still runs, because conditional expressions actually take whatever is inside of the parentheses and coerces it into a Boolean. And then it reads that Boolean true or false. So as you know, any number or any string with length, and by any number, I mean any non-zero number coerced into a Boolean is true. They're truthy, right? So that means if this was a 0, nothing would happen. Because it's not saying, okay, if 0, okay, let's make this exception for 0, we won't do it. No, it's saying, if it's coerced into a Boolean, what is it going to be? It only reads true or false, okay? Does that make sense? So you can do, like, if this, or you can do if not 0. That's true, right? Not 0 would be coercing that into its opposite truthiness, right? So we get true for that. Does that make sense? Let me see. What else can I talk about? So, okay. So there's 2 other operators that I want to share with you guys, okay? It's the AND operator and the OR operator. So AND is 2 ampersands, and OR are these 2 pipes, okay? So if I say, what if I want, like, in my if statement, like, if let num equals 5, right? So if num is less than 10 and num is greater than 3. We get yes, right? This will run. That's what the and is saying. What if we changed the num to 1? Will this run? No. Because, yes, num is less than 10, however, it does not satisfy this. 1 is not greater than 3. And because we're using the ampersand, both things have to be truthy. And you can do another one, right? And num is not equal to 5, right? So if this was 5, it wouldn't run. If it was 6, it would run. And you can chain these as much as you want. However, what is actually going on here behind the scenes? What if I did let what am I equal to 5 and 10 and null and true. What am I? What am I going to be? What is this going to be? It's going to be null. Because what ampersand is actually doing is it's either going to return the last truthy thing or the first falsy thing. So this actually returns a value. Like if this was the string null, so that's just a regular string, right? This is now going to be true. And if I change this to 44, it's going to be 44. Because we made it through, like what happens is, this is like 5 plus 10 plus null plus 44, right? We go left to right. So we do 5 and 10. That will return either the first falsy thing or the last truthy thing. The last truthy thing is this 10, right? So this actually returns 10. Now we do 10 and null. The first falsy thing or the last truthy thing. That means that this actually returns null. And then we do null and 44. And that actually returns 44. Does that make sense? So like up here, we're using all of these expressions, right? But like, if what am I, like I won't do if what am I, if I do this inside of here, what the if statement is actually going to do, oh, because this is a string, by the way, is it's going to, this returns something, right? This is an equation. It returns something. It returns this null. Because once we hit that null, this returns 10, remember? So 10 and null will return null, because null is the first falsy thing it found. So then it returns, so then we do null and 44. Null is the first falsy thing, so that's when it returns. Does that make sense? So, now that we have that, what if we have this? What do you think what am I is going to be now, using your own intuition based of how the AND operator works? This is now the OR operator.
All
everything is a little reversed. What we get is hello. Because what OR does is it returns the last falsy thing or the first truthy thing. What OR cares about is if we do this in an if statement, if I console.log this here, and I did like false, and I did null here, and I switched these to ORs, right? What we get is yo. We get that yo. Because we do null or false, that will return the last falsy thing. So false or null, that returns the last falsy thing. Null or 44. It returns the first truthy thing before the last falsy thing. So there only has to be one truthy thing in your OR. Does that make sense? It is the and OR are opposite. Yeah, go Steve. You got a question?
What if you had the second string there that you have null, false, nan, hello, and then hello and true?
I think this would just change to true. Yeah.
Okay.
If I change this to I think it would just be true. Yeah. Because it goes left to right, right? This is like a ridiculous statement, though. You know? Like, you would never want to do this. You can do something like this. Group these two things together. Oh, wait, whoops. Nope. Nope. Group the ORs together and this. Make sure these three things, there's something in here and there's something in here. Then we would get not a number. Because this will return not a number, and this returns true. So not a number and true would return not a number, right? But this is confusing. This is just ridiculous.
So wait,
Yo.
for OR,
Yeah.
it returns the last falsy thing or the first truthy thing?
Yeah. And returns the first falsy thing or the last truthy thing. So it's completely different. How's everybody feeling?
Wait, you said and returns the last truthy thing?
And returns the last truthy thing, but first it returns the first falsy thing, right? Oh yeah. Okay. Somebody asked about spaces. A space is a valid character. So a string with just one space in it is truthy. Okay? A string with 1,000,000 spaces in it is truthy. Even though it looks to you like there's nothing in there, those are valid characters, right? So this lecture was mostly about rules behind the scenes that are happening inside of your code that you need to be aware of. You need to be aware of these things because it's going on whether you like it or not. Things are being implicitly coerced whether you like it or not. And the and or operators are super, super powerful to use, especially in if conditionals, okay? So, any final questions before I go into the slides? The slides are kind of like the same stuff. So let's do this again. So here we have our slides, right? So we'll talk about explicit coercion, implicit coercion, concatenation, loose equality operator, coercion to Booleanness, what's truthy, falsy, conditional expressions, bang operator, and logical operator. Okay? Got a lot of things to talk about. Types, we have number, string, Boolean. These are all primitive types. Other primitive types are null, undefined, and symbol. We are not going to talk about symbols in this course because they're very new data types and you don't really need to know about them, okay? I don't use symbols ever. Complex or object types, functions and arrays, and objects. Arrays and objects we'll cover later. The major difference between primitive and complex types is that complex types can be mutated. We'll talk about that later. Primitive types are passed by value. Complex types are passed by reference. We will talk about that later as well. I think like Thursday we'll talk about that, okay? So don't worry about that now, but if you want to like take a little brief intro to Thursday's class, you can look at the pre-recorded lecture or whatever. So explicit coercion. Explicit coercion happens when we use one of the built-in global objects to create a new value of type, okay? So that's something that we are writing. We are telling our code to make this, right? So as you see, let num equals 10. We const.log the type of num, and what we get is number. Let string equal string and pass in num, right? String is available always. It is the global string object in JavaScript. We console.log string, and we see that it's still 10 in the terminal, because you can't really see things in the terminal correctly, but we console.log the type of string, and we get string. Any questions on this? Hell yeah. All right, cool. So let's go on. So we have... Oh, shit. So as you can see, the same thing goes with numbers, right? So string is equal to the string 1000, and we console.log that type, and we see string. So let num is going to be number passed in string, the global number object, right? Console.log num, console.log type of num, and we get number, but we still see the 1000 in the terminal. Any questions? Same thing except with numbers. Implicit coercion also changes the type of value, but unlike explicit coercion, implicit coercion is something that JavaScript does for us behind the scenes. This behavior can be very helpful, but it's important to understand how it works so we can anticipate what our code will do. So let sum equal 20, right? Let concatenated string equal 10, the string 10 plus the string 20. Let not sure equal 10 plus 20. Will this throw an error? Will it return a value? So as you can see, our sum, 10 plus 20 is 30. That makes logical sense. You make the string of 10 plus the string of 20, we get the string 1020, right? Because when you concatenate strings, they're added onto the back. Not sure, we still get 1020. That's because JavaScript is coercing this 10 into a string. Okay? That's what's happening behind the scenes. The plus operator will implicitly coerce a number to a string if you try to add it to a string. So as you can see, the string 10 plus all of these numbers, we get 10, 20, 30, 40, 50. Does that make sense? Because the string was at the beginning. If the string was at the end, if 50 was a string and 10 was a number, we would get 30, plus 30 is 60, plus 40 is 100. So we would get, plus the string 50, we would get 10050, right? Just depends where the string is. Where does 120 come from? Yeah. Oh, yeah. Exactly what I just said, right? Does this make sense? Yeah.
Yeah. So if the first value is a string, every other value will be converted to string. But if the last value is a string and the rest are non-strings, that last string will be left alone. It won't corrupt the others.
No, because like order of operations, right? We read left to right. So we do 10 plus 20 first. Like the number 10 plus the 20 first, and we get 30. Then we do that 30 that we got there plus this 30, right? And these are all numbers. And then we save that for the end. However, here, the first thing we do, left to right, we do a string 10 plus the number 20. So that is 1020. So then we do the string 1020 plus the number 30. And that will convert that 30 into string, so on and so forth. Make sense? Cool. So avoid using the double equals operator or I'm going to lose my mind, okay? The double equal operator is not good. It coerces things behind the scenes and then compares them. Look at this chart. 10 double equals 10 is true. Cool, that makes sense. 10 double equals string 10 is true. It also makes sense when we look at it, but it shouldn't, right? Because they're two different values. The string true is equal to the value true. That's false, which doesn't make any sense. And I showed you that false double equals empty string is true, which is weird. And then true double equals the string 1 is also really weird. So what happens is JavaScript actually coerces both of these things to numbers. So if you try to coerce true into a number, you can do that. It's 1. Coercing false into a number is 0, because that's what life is, right? 1s and 0s. So pretty much it coerces both of those things into numbers and then compares them. But true and the string 1 are just not the same values. They just represent completely different things, right? So don't use this. I swear to God, don't use this. Okay, values can be coerced to Boolean values too. So we say let new bool equal Boolean and you pass in I am a string. Will this be true or false? It's true. Because any string with length coerced into a Boolean will be true. Okay? When coercing a value to Boolean, JavaScript uses rules to decide if a value should be coerced to true or false. Values coerced to true are called truthy. Values coerced to false are called falsy. Most values are truthy. Strings with length, any non-zero numbers, all arrays, all objects, even if they're empty arrays and empty objects. We'll talk about arrays and objects we'll talk about arrays at the end of class tomorrow, actually. Okay? These are the only falsy values. Empty string, 0, null, undefined, not a number. Okay? Engrave these in your head. This is some memorization, okay? Recall how an expression works. So if 5, console.log in the else console.log in the else. So obviously we get in the if. If the expression below evaluates to true, the if block will run. But 5 doesn't evaluate to true. 5 is coerced into true. That's what the conditional actually does. What if the conditional expression evaluates a non-Boolean value? What it does, JavaScript will implicitly coerce the result of an expression in a conditional to a Boolean value. If 10, it's 0, right? So we got the yes and we got the no. If 10, console.log yes, else console.log no. 10 coerced into a Boolean is true. So that means that this is going to run, this line 4. Then we look at line 10. If 0, no. 0 coerced is false. So if false, no. We go into the else. So we get that console.log else. Right? Any questions on this? No. So now here's the bang operator, which is shorthand for coercing something into a Boolean. However, the single bang reverses it. Okay? So bang true, we get false. Bang ABC, we get false. Bang 100, we get false. Bang array, bang object, we get false. Okay? So bang is reversed. The double bang reflects the truthiness. Okay? So bang bang, we get true. Bang bang, string, we get true. Bang bang 100, we get true. Does that make sense? This is going to be a little, this is just going to take time for you to get adjusted to how these things work. I understand that these are all new, operators, the bang operator, the and operator, the or operator. I don't expect all of you to just click, right? Just click and you use it from the get-go. This is going to take practice to get right, okay? So just bear with me, okay? So here we have logical operators. So if 10 and 20, we console.log both 10 and 20 are truthy values, right? That makes sense. Ampersand reads as and. So if you say this aloud, if 10 and 20, that makes sense, right? These are both truthy, so we'll run. That's why you should be reading this out loud, okay? If 10 and 20. Logical operators also coerce values to Boolean values. Well, no, the logical operator doesn't do this. So the if statement is doing this. What is happening is this logical operator is returning the 0, right? So and returns the first falsy value or the last value if all are truthy, right? So return value 1 is equal to 10 and apples and 0 and null. Return value 2 is going to be string lucky and string number and 7. So as you can see, return value 1 is 0 because 0 was the first falsy thing that was encountered. And then 7 is going to be return value 2 because that's the last truthy thing. Does that make sense? You guys sure? All right, dope. All right. So now, our OR value, our OR operator, is pretty much the same thing except reverse, right? OR returns the first truthy thing or the last value if all are falsy. Let return value 1 null or undefined or happy or pumpkin. We get happy because that's the first truthy thing we found. Here we have false or null or 10 is less than 0. What is this? The less than sign actually returns a value. That's an equation, right? So this would be false. 10 is not less than 0. So false or null or false or not a number, we get not a number. Because that was the last falsy thing. And that's our recap. Any questions? Who's confused by all of these rules? It's okay to be confused. This is fine. I just threw out a lot of like these random things that don't make any sense, okay? If you're confused, just take it easy. However, if you could follow me when I'm talking, if you follow what I'm saying and you understand like, okay, so I can see how this works, but you can't do it in 15 minutes when you're doing your workshop problem, that's completely normal. All these things take a lot of time to just like kind of ingrain in your head. By the time you're done with boot camp prep, all of this shit is going to be like breathing to you, okay? Really. It just takes time. And just trust the process. Just do all the workshop problems and trust, okay? Any questions?
Are we going to do another lecture, or are we going into problems?
We're going into problems. No more lecture. So if there's no other questions, then I will break you guys up into new rooms, okay? Is everyone cool with that? Let me